Good afternoon, guys. I'm Chris, and welcome back to this Wednesday's episode of Rift Amps. Right, the MJW L640 MJW, or Martin Whelan, was a fantastic amp builder here in the UK. He was based originally in North Derbyshire and then moved up to the Scottish Highlands. Gave up amp building a good couple of years ago now. In fact, when he did, I bought all of his test equipment, stock, everything he had basically. He sold everything to me. Anyway, so this is a 2015 amplifier, I believe. It's essentially a hot rodded Marshall. It's got a switchable preamp, which switches between, is it a JTM 45 and a JTM 50? I was just reading the spec. Single channel with switchable preamp circuits between a JTM 45 and a JMP 50, labeled Blues and Rock. 6L6 output valves, which is why it's 40 watt and not 50, because the way he's decided to run it. It's got an effects loop, half power, pento triode switch. Apparently it's a turret ball construction inside, and the customer does own the matching speaker cabinet, which originally had Celestion 65 creambacks in. So anyway, it's come into me today because its current owner has only had it a couple of weeks. He's bought it on the second-hand market, and the amp has developed a hum. The hum is not present when it's in standby mode, but flick it into play mode and the hum is there, and it's not affected by any of the controls, which might give us a clue about where we need to go with this. The customer has already done all of his idiot checks, so he's tried plugging the amp into different power sockets on different ring mains. He's tried different cabinets. He has replaced the valves inside and it didn't make a difference. So he's done pretty much everything that he can do and has now brought it in for a tech to have a look at it, which is what we're going to do. So before we get this thing apart, I think it would be a good idea to quickly get it on the test bench, have a listen to the hum, measure it, see what's going on with it, and then we'll pull the chassis out and do our basic visual inspection. Okay, we are on the test bench. I have got FFT plot set up on the speaker, so we're going to measure any hum that we find. I've also got the second microphone on there too, so I'm going to boost the audio just to make sure that you guys can hear it. So it's going to be worse on video than it actually is in real life, but we need to try and make these things clear. And you'll be able to see on FFT plot, link in the description by the way, exactly what frequency any noises and hums are. So the amp is currently on, but it's in standby mode. I'm going to go quiet. I'm going to boost the audio, flick it into play mode, and then we will be able to both see and hear what sort of hum is going on with this amplifier. As you can see, I've set all the controls at noon, and nothing in the input. In standby mode, it's currently pulling 22 watts out of the wall. So I suspect the standby mode is breaking the high voltage supply inside the amplifier. But anyway, let's have a good listen and we'll go from there. I'll give it 5 seconds at first for FFT plot to settle back down. You can see it moves with my voice. So we need to get rid of any of that first. I'm going to be as quiet as I can to not interfere with the reading, and we'll go from there. Okay, so there we go. Definitely a hum. Now, the loudest frequency there was 200 hertz, which is a harmonic of 100 hertz, which will be our rectified hum. So I think it's definitely a hum from the high voltage supply in the amplifier. So we're either looking at possibly a faulty mains filter cap, or we're looking at a grounding issue. So let's get this thing split apart, have a look inside, find out where we are. Right, Q&A time then. Before we start, weather update for everyone who's into that sort of thing. It's miserable out there. It's absolutely chucking it down. This is the crap weather we should have had in April. We're now getting at the end of May. It's June next week, right? What? I never get it. But us Brits, we do love to moan about the weather. We really do. So yeah, hopefully it cleans up for the weekend, because I am racing and I would really like it to be dry. But it is what it is, I guess. But yeah, anyway. Just working on this Ainsley Lister signature build. Just doing my heater jumpers at the moment. So on your preamp sockets, pins 4 and 5 are tied together if you're running 6-volt heaters. And so I just put little jumpers in just to make it easier in the long run. So anyway, a comment on the Panoverb video from Stanley Joyce, who said, I talked to the engineers, etc. at the NAMM show. They throw a small amount of well-made units and the rest are crap, so that there are a few people who say that they have never had problems, while the amp techs that get hit with the mounted and faulty units post-warranty, etc. i.e. all of the Blues Juniors and Hot Rod series. Some people win the lottery, some don't. Well, I hope that's not true. I hope that Fender aren't deliberately sending out good units to, the YouTubers and reviewers and stuff, and artists, and then the actual stuff that the punters buy are crap. Well, I mean, we know they are crap, but yeah, I just hope that's not true. I don't think that's the right way of going about your business. But yeah, I mean, if that is true, that's quite shocking, isn't it, really, Stanley? So it'd be interesting to know more, who you spoke to, where you got your information from, and I hope we can verify that, because if it is true, that's not good at all, is it? Ben Rudge says, I have just taken delivery of Elysium number 173, the one that I was building in last week's video, and it is absolutely brilliant. It doesn't do the spitty fuzz thing, and this is to its credit. Well, yeah, it's not designed to. It's a low gain fuzz. So the sweep of the pot is really usable. The response to guitar volume is ace, so it's very easily controlled. And the voicing switch gives 2 genuinely different EQs rather than just being decorative. Yes, that's exactly the point of it. It's I never understand voice switches that kind of do something but not enough. And so the Elysium is designed to straddle that territory between overdrive, distortion, boost thing and fuzz. So it kind of just rides that peak, and then you can go either side of it, which is great. Instant Dark Side of the Moon time solo territory. This one's going straight on my board. Cosmic. Oh, well, thank you, Ben. That's very kind of you. I'm glad you're enjoying it. It's a cool pedal. Although I did notice that the Pedal Show recently did a video on, low gain overdrives and fuzzes, and they didn't include mine, which... and they've had that for a while now. Maybe they just forgot, but I would have thought my pedal would have been perfect for that. But, you can't win them all. Right then. Oh, I forgot about those. Martin was quite a fan of using toroidal mains transformers in his amplifier. So what can I see? 2 6L6s, 3 preamp valves, toroidal transformer. We've got output transformer there, and I assume that's a choke. Couldn't be anything else, could it? There's no reverb. Oh, it says something inside. Up in the corner there, can you see MJW amplification number 185, June 2015. There you go. Okay, right then, so let's pull the chassis. So we've got what looks like JJ can capacitors. A Hammond choke, yeah, 15 Henry at 100 milliamps. And a nice beefy output transformer with a stack that is approximately 1 5/8. Right, okay, what do I need to do? Oh, I need to get a chassis stand. Okay, so it's JTM 45 sized chassis, so it should go the same size as the Ainsley Lister. And it is. Daniel Saturnino says, a bit of red plating ruins new valves. We're talking about the Lazy J here. Yes, it can do. It entirely depends how severe the red plating is, how long it was red plating for, and of course the quality of the valves. And sometimes you're just unlucky. So yes, some valves can tolerate red plating for quite a long time. Others don't, and and that's not necessarily a particular brand or model of valve. It could be just that particular one you've got. And so there's lots of things. Unfortunately, those the ones that were in it, one of them was okay, the other one is kaput. So the one that's okay will be good enough to use as a spare, or maybe in a single-ended amp. But yeah, it's no good for use in a push-pull. It's beyond cooked. Paul says, hi Chris, could you kindly explain at some point how you fix the conductive board on the Lazy J? Thanks for another interesting video. P.S. Just got back from seeing Ollie Knight-Smith, our good friend Ollie, from playing with Alice Armstrong Band at Tame Jazz and Blues in Teignmouth. Very enjoyable. Well, I shall be sure to let him know. He is a viewer and a channel member of this channel. So, nice one, Paul. How did I fix the conductive board? Well, it had the same issue that you find on a lot of 5E3s that use that board material. I've done a quick board layout for you. So there's a high voltage node here, and this is the eyelet that then feeds the grid of the output valve. So there's an underboard wire that goes off from there and then down, and what you get, the conductive path is up like this. Hopefully you can see that. So from here, you get a conductive path up there. Now, we were lucky in that the conductive path was actually on the top side of the board. If it was the underside of the board or even the insulator board, it would have meant I've had to pull the board out and down. And what I was getting, you've got a good couple hundred volts at this point, and we were measuring after a long period of time, we were getting nearly 2 volts at this point here. So there was a conductive path along there. The easiest way to do it, or the first step, obviously physically clean the board. So isopropyl alcohol, some Q-tips. If you see anything physical there, you might have to scrape it off. You know, some old detritus or whatever. But I soak the board with IPA there, and then I use a heat gun to dry it off, and I do that a couple of times, testing in between, and you can actually watch the voltage level drop over time. So that's what I did on that one. That's where the high voltage was coming from, this node here up to this point here. So yeah, it was somewhere along there. There was a conductive path through the board, and yeah, a bit of IPA and heat, and it generally cleans it up, and that's all that amp needed. But it's you do see it on old 5E3s too. It's not unique to the Lazy J, but it's a classic example of, if you want to build an amplifier that lasts, don't use that board material, because you're only ever building in a problem for the future. Whereas if you use, a non-conductive material, you'll be absolutely fine. Okay, I haven't discharged it yet, so should we do that first? Okay, so if we find, here's an earth down here, got my discharge cable, and there's a filter cap. We put the amp in play mode, we should be good. So what does that do then? Where does that switch from? Can I follow that wire around? Comes from a HT fuse, yeah, that makes sense. And then goes onward to somewhere underneath the board. Gonna have to buzz it out. Okay, anyway, you can see quite a nicely well-made amp. Some things in here done very well, other things done okay. How do I want to word this? As we all know, everyone's got their own different build styles, right? And each of them equally as valid as others, but sometimes you see things and you go, oh, that's a clever way of doing it. Sometimes you see things and you think, there's a better way of doing that. Not necessarily means that it's not good, it just means that there are more optimal ways of doing things. That's what I'm trying to say. I think that's a fair way of doing this. So he's got a very nice star ground going on down here, as I said. Some nice bus bars going on. He's clearly thought about his layout. Hasn't used hasn't used 4-1. He has used what I assume is something similar to FR4, although it's brown, not black. FR4 usually comes in black or that translucent green. So is it phenolic or phenolic? I can't remember. Phenolic, I think. But you can see high quality components throughout. Ones that we know are good and that we know it works. Very clean build. Soldering is absolutely beautiful. So just doing my visual inspection. We've got some nice chunky screen stoppers on the output valves. His input grid stoppers are 4K7s on 6L6s. Okay. We've got a full power, half power switch, which is pentotriode. Yep. Configured in the normal way. Got 1 ohm resistors on the output valve cathodes. We've got 100 ohm resistors on the heaters for an artificial sensor tap. What else can we see? Anything in there that stands out as unusual? Apart from the loop. Oh, customer says the loop is sometimes a bit intermittent, so we'll make sure we clean that all out. But no, this is nice. This is good. Somebody who actually cared about the product that they put out. So, what else we got to do? What else have we got to do? Oh, look, there's your bridge rectifier up here. Mounted on the side there. Cool. Okay. Let's get this on the bench then and start doing some very basic tests. On the valve microphone, Steve Mumbling says, no holes to allow airflow around the valve. Strange. Well, Steve, you tell me how much airflow a 6AK5 running quite cool actually needs. If you look at the data sheet, we're in the receiving tube manual, 6AK5, maximum plate dissipation is 1.7 watts, but in that circuit it's run nowhere near that. It's actually run surprisingly cool, so it just doesn't need it. It just doesn't need it. So not strange at all. It's well within its design parameters, and if it did need some convection cooling, I'm sure the manufacturer would have added it. Okay, so we're going to start with the absolute basics, which will be, so I need to get more light on this. We're just going to check that things are properly grounded. And the easiest way to do that, as long as you know what you're doing, is you can get a simple test lead to your main grounding point. Nice and secure. Remember, I've got the chassis on and it's live now, so I am being super careful. So now I'm going to start prodding around, one hand in my pocket. And we'll just start testing all of the main grounds that we can see. So we'll start with the two filter caps here. We've got these grounding points there. No change to the hum. We'll come over here. No change to the hum. Right, what about this is our bias supply here, and also a ground for this filter cap. So we'll just check. I'm making a ground there. Connection, does it change? No, it does not. Okay. We've got our bus bar along the back for our pots. Connect that on, no change. Our preamp bus here. No change. What about our input jack? No change. Speakers? No change. It's all high voltage. It's fixed bias. Okay, so that was easy enough to do. Absolutely easy enough to do. Just a very basic, add an extra ground to all the main ground points in the amplifier, both audio and power supply, listening for changes. Nothing changed. So that confirms that the wiring integrity for the grounds in the amplifier, or at least the ones I've checked, are okay. Hannah Worth says, regarding the bass channel of the Selmer treble and bass Mark 1, it's Selmer's take of a blonde Fender Bassman amp, the 6G6. Do you know what? I did not know that. I'll have a look. A common mod would be to add a 500 to 1000 picofarad cap to the phase inverter input. Nice amp. I'll be interested to know more on that. So if you've got any more information, do let me know. Email repairs@riffdamps.com. I'll do some research myself, but I'm interested to know why that's a common mod, what they're hoping to achieve and why. Were they trying to fix an issue? Were they just trying to improve the sound? What is it? But I've not come across that. But it's interesting that it's... does it look like a 6G? A 6G6? I'll have to double check that. But anyway, thanks for your comment. Good tip. Right, so the next stage then is to test the filter caps. And so what I've done is, first of all, I'll say that this amp is a little bit backwards in that the two CAN capacitors are further down the B+ rail than you would expect. So this is actually the reservoir cap. This is what the rectifier feeds. So that's the first stage. Then you've got this node here on this cap, then this one, then this one, then this one. So this is the final preamp node. So it'll be +1, 2, 3, 4, 5 filter stages. Okay, I've gone through the B+ rail with the oscilloscope, and there's pretty much no ripple anywhere apart from the reservoir stage, which is what we're looking at now. Now this is kind of where I would expect it to be, more so on the upper limit, but this is in fact with, zoom you out, oh I've locked you in place, you can see I've tacked in another cap in parallel alongside the one that's in the amp, and that's reduced the ripple by half, which says to me that my first port of call now is to swap out this cap and measure its improvement, measure any difference and see if we're getting anywhere. But Paralleling this cap with every other stage makes no difference, but we do get a big reduction in hum when I parallel the reservoir cap with an extra 47. So what I'm going to do, I suspect that this F&T is failing, so I'm going to swap that out entirely. In fact, the easiest way for me to do that would just be to snip the leg, lift it out, and then run this one in its place as currently shown. And if the ripple level drops even further, then we do know, well, that pretty much confirms it, that this cap is knackered. So hopefully so far quite an easy diagnosis, but I suspect I've just shot myself in the foot and this isn't going to make a difference. So we will now go, actually the first thing we'll do is, can you see the voltmeter? Well, if I show you, at this point we've got 420 volts DC. All right, and I've got, with this cap in place, 2.3 volts RMS ripple on the B plus rail. If I quickly remove this from circuit, the hum increases and we go up to nearly 5 volts of ripple. So yeah, definitely something going on there. So that's what I'm going to do. I'm going to discharge the amp, just snip this out of circuit, and then this one can be in its place, and then we can redo our test. But we're at 2.3, so we're at 5 volts. Cap in place puts us to 2.3. I'll write this down and then we'll see where we are after the fact. So amplifier off, discharge cable on. So that's draining the amp now. Confirm with my meter. At the same point now, we're down to 4.2, 3, 3.5. See, that's discharging. So we'll wait till we get to below 1 volt. Come on. There we go. Right. Okay, amp is off, discharge thing in place. Let's get my snips. Right, so now we want to come back onto that point with my sub cap. You measuring ripple with that. So same ground point there. We all hooked up. So that cap is now not in circuit and this cap is doing the job. Discharge cable off, amplifier on. Well, I don't hear no hum. I don't hear no hum. I do not hear any hum. Perfect. Job done. Right, so that cap is faulty. I'm going to go ahead, discharge the amp. Going to solder a new cap in place there. Retest our repair. Test our repair. Confirm that we're all good on that front. And then we've got a couple of other little jobs to do on this as well. So there you go. Faulty reservoir cap. Things happen. It's an F&T, and can we see the date on it? Well, I guess it's around the time the amp was built, which was June 2015. So pretty much 10 years old. I mean, well, there you go. Right. Okay. What am I doing? Amp off. Discharge cable on. Scope out the way. And then we get ourselves a 47. Now, have I got another F&T 47? I think I've just used the last of mine up. 47. No, I've got loads of tads. That's all right. I do like the tads. So we'll just stick another one of those in. 105 degree cap. 47 microfarad, 500 volt. We'll get that soldered in. Test our repair. And then I shall come back to you shortly. David Lovell Bass says, what is your bass, Chris? Never noticed it wasn't a Fender 51 reissue before. No, it's not. It's It was built for me by the fabulous Anthony Ryder, who also built the Rift Burst and the Black 54 Custom that I've got. Anthony was very lucky quite a long time ago to work on Guy Pratt's 51 telly bass, and so we decided, well, when I wanted one made, because I always like them, I always like the look of them, I love the sound of them. They're quite a polite bass, but you can get some really great sounds out of them. I know a lot of people associate them with Sting and his tone, but you can do some really cool stuff with that. I absolutely love it. So I had that made for me by Anthony. It's a one-piece body. It's got a slightly flamed neck. I'll do some pan over shots so you can see what I'm talking about. It's just a really nice, well-made bass that he did for me. Yeah, what else got to say about it? Oh yeah, it's got the most wonderful pickup in it as well. His brother wound that pickup, and it's the first guitar or instrument I've ever bought where I haven't immediately wanted to swap out the pickup. It was just bang on from the absolute beginning, just perfect. Did everything I wanted it to. But as I said, it's quite a polite pace. So you compare it to a Precision style. Precision's got a lot more thump. This one's got a lot more character and clarity, which for me is a good thing because I'm really into those vintage bass sounds anyway. But yeah, that's a killer bass. Big fan of it. But I am on the hunt out for a jazz bass as well at the moment. So I'm trying to find a nice player grade vintage example, probably a 70s one or something, if I can find one that's a nice weight. I missed out on one recently, which was quite disappointing. But you know what they say, if you miss out, you obviously weren't meant to have it. Well, I may have called the F&T cap too early because having soldered in the tad into place, the hum returned. Now I've desoldered it and I've put the other tad back in parallel, well, in its place, and the hum is gone. So, and the only difference is how it's grounded. So is there an issue around the way that the cap on the board is grounded than it is when it's done this way? So that's what I need to investigate. But this is getting fascinating because one, it's thrown me a curveball, and two, I've made an assumption, haven't I? Or the previous tests that I've done led me to make an assumption which has turned out to be incorrect, and that the grounding, what I assume to be is a grounding issue, is well, there is a grounding issue when I assumed that there wasn't. So yeah, this is brilliant. I'm loving this. Fantastic. Love a good head scratcher. So I'm going to do a bit more work and I'll come back to you when I find something. But what I'm going to stop doing now, because we're in high voltage, I'm going to stop diagnosing stuff on camera and I'll just come back to you once I've actually found stuff. I'll try and demonstrate what I find as well once I actually get there, but I don't want to be messing around connecting and disconnecting stuff, measuring stuff on camera, because that's how you make mistakes. And I really don't want to get zapped. I've just come back to this after about 25 minutes of thinking. Often it's good to step away and just reassess and, process what's going on. And I've realised I've been approaching this from the point of view that this is an inherent design flaw in the amplifier, right? That's where my mindset has been and the kind of approach that I've been taking with this so far. At least in trying to diagnose what this ground hum is. But as you remember I said at the start of the video, the customer said it was fine and this hum has developed, so something changed. It's not an inbuilt issue to the amplifier from the beginning. Now when I have this filter cap, or this one, grounded directly this way, it's fine. There's no issue. But when I ground it along the this ground bus rail, which is shared by the bias supply. And also, I mean, this is what I've been trying to do. There's a secondary ground here that comes from somewhere else, and I've yet to locate that. So when it's something in that grounding point, sorry, in that shared ground point, on that ground bus, as we'll call it, the hum returns. So I need to do some further work along this point. I'm going to have to start buzzing stuff out and work and reverse engineer it slightly, because there isn't a schematic for this, but I need to understand exactly how this thing is wired, and then I can find what's changed. Okay, this isn't an inbuilt problem, this is something's changed. So unfortunately I'm not going to be able to get you an answer on this in this video. I've run out of time before I have to get this thing edited and uploaded. One for the channel members on Tuesday evening, and for the rest of you on Wednesday afternoon when the video goes live. So you're going to have to wait till the next video to find out. But rest assured, I will let you know. But I wanted to make that point in that I had automatically assumed this was a design issue, which is not. And that was the angle from which I was trying to diagnose this, when actually it's something's changed. So I need to go back through and work out exactly what's what and why is why. But isn't this fascinating? Isn't this fascinating? I mean, this grounds, when the cap is grounded to the ground bus at the back here, that goes to the same star ground as it would do if I did it this way, right? So it shouldn't make a difference, but it does, and we have to understand that. So I'm going to carry on. I'm going to do a bit more investigation, see if I can work out what's what, who's who, and why's why, etc, etc. But yeah, you will get an update, just not in this video. Well, that's it then, guys. Thank you very much for watching once again. Frustrating, I know, that we didn't get to the bottom of the MJW, but we will. So please give this video a thumbs up if you enjoyed it, or your comments and questions down below in the comments section. Subscribe and hit the notification bell if you haven't already. If you're feeling super generous like these guys have, why not join the channel? And I will catch you all at the next one. whilst we're on the subject of race cars, I may have done a little thing. Now, I have been saving up for, I was saving up for a spare shell for my race cars, just in case I had a big accident and I needed to quickly get it fixed. But this thing came up super cheap, so cheap I couldn't say no. Absolutely had to get it. BMW E36. It's an ex-compact cup car, so originally would have had the 1.9 4-pot in it. This particular one hasn't been raced for a couple of years. It's actually had a 2.5 swap. It's got an LSD fitted, but it's in, yeah, reasonable condition. It's been hibernating all the way up in Scotland, but it's come down. Hello, here I am. And can you see inside? There we go. It's a surprisingly clean car. It needs a bit of a tidy up, a bit of a clean. We go to wide mode. But yeah, managed to snag myself a spare race car. I've got nowhere to keep it, so it's going to have to stay on the trailer. I'll get a cover for it. But yeah, wasn't the race car I was looking for. Wasn't the race car I wanted. But for the price I've paid, which is very cheap, not just for a race car, but for a road car as well, because the guy had to get rid of it. So yeah, really happy. Snagged myself another race car. I'm not going to race it in the championship. I think I'm just going to do 1 or 2 events this year, because it's not currently race ready. It needs a couple of jobs doing, but we'll get some. We'll get it race ready. We'll do a couple of events in it, and then I'll sell it next winter.